Hello there DIY builders. Today I will start a project of a 3-axis camera gimbal for the Sony Nex5N camera. So before I go, I'm not gonna do all the cutting there. If you just want to see how do I handcraft fiberglass and carbon fiber, check the link below. I will be going through the process. What am I thinking of? What my technical decisions, step by step. So I have the motors. There's a RC timer 5010s for the pitch and roll axis, and there's for the yaw axis is 4108 130T motors. About these motors, before I go, if you're gonna get those motors, please do check the windings inside, because some of the motors they had a loose wire, and if I would have spinned them without checking, I would have ripped the wire off. So just double check them, please. Right, so if you're interested, let's make yourself some popcorn and off we go. So for the start, as it's gonna be controllable. I mean adjustable for the center gravity. So first I have to find the measurement. Where is my center gravity? Once I find the center gravity measurement from that hole, I will make it adjustable. Once I have one axis, then I will start moving onto the other axis. So the gimbal itself will be it's similar to these things as a build for GoPros. It's a simple triangular to save some weight, and of course everything will be adjustable for the perfect balance. Right, so let's find these measurements and start cutting the fiberglass. Okay. After finding the measurements, here's what I come up with for the start. So that's the pitch. That's the pitch angle. It's gonna be. So finding the center of gravity of a camera, I know the measurement from the center gravity to the point where it's gonna be screwed on. So the hole will be enlarged later on for adjusting the camera. Also got the holes right on for the IMU mounting. And once I know this center of gravity, I can cut out one plate. So I put the camera to find out this center of gravity. So after I know that center of gravity, I know the measurement that from that point is a 30 mil from here. So I could cut out this plate for the motor to be adjustable. There will be a second plate, so I can adjust the height. So from this point, 10 mil up and 10 mil down, it's gonna be plenty. So I have this one glued on. As you can see, they are interlocking each other. So a single PCB, it's not fiberglass PCB, whatever, it's not gonna be solid enough. So what I will do next, I will double it that, and I will double it this one, and when it's interlocking here, I will interlock it the other way around. So this way the stick on a CA works, like it gets very solid there. So with all this interlocking, that's how you know that I'm a carpenter. Right, let's get that finished. When that's finished, then I can refine all the rough cuttings there. Okay. So I got my pitch angle finished there, and lighten and the whole lot. So that's, as I said, I enlarged the holes, and it's gonna be adjustable for the balance. That's gonna be for the motor. Adjustable the height. Okay, so with this, what I did, I doubled the PCB, the fiberglass, the same. So as I said, the first one is interlocking as it the girl and the boy, and the second layer was interlocking a boy and a girl. you know, the 69. When that one's done, I cut the groove in here, and also sunk in some fiberglass by angle. This way it's bloody very stiff, and everything is set on the CA glue. There's no flexibility, not that way, not this way, not anyway. So let's stick it on the weighing scale, see what we have here. 16 gram. I can live with that. Okay, next step is to put the motor on and then try to find the center gravity. What will be my angle for my roll angle? Right, moving on. Here's some more progress on it. Once I found the CG of with the camera and with the motor on, there's gonna be my center, and the holes will be enlarged. Now the distance, I got the camera the furthest down that could be possible and the furthest back. So this way I found my distance from the motor shaft to this point. Now the roll angle is wider, and it's gonna be double as well. On top on that, I got the flange on because on the pitch angle it carries only the camera weight, and the roll angle carries camera weight with the pitch angle and with the motor. Plus the distance is a bit longer, so it has to be more solid. So here's what I'm doing. They're interlocking each other. It's gonna be stuck on CA. On top on that, it's gonna be doubled, and another bit will come here by angle. Once I get that refined, then I will drill the holes a little bit to enlighten. I will see that after I check the flexibility of all the stuff. So here's what I have so far. I made the roll angle. The fiberglass is double, and I drilled the holes. And before I move on, I just wanted to check how flexible it is. And with that bit added, like, it's zero flexibility, nice and stiff as me in the mornings. So the motors, I noticed that there's one motor, they are exactly the same, but there's one motor has a 3.17 whatever shaft, and this one has a 4mm shaft. So this motor will go on a roll axis, which will be better. So the next step will be finding the center gravity for my third axis, for my yaw axis. So we're doing roughly similar to this one, but it's gonna be even wider, and it's gonna be even more solid, because there's a pitch axis. You're bearing so much weight on the roll axis, you have more weight, and you have the most weight on the yaw axis. That's why the yaw motors have to be more powerful. They working the most. So it's all good, it's all nice. It will be ready for painting shortly. Now let's stick it on a scale and see what we have now so far. Okay, we have here 255 grams. That's two motors and roll angle and pitch angle. So far so good. Let's move on the yaw angle. I strapped camera stationary just with the tape on, just to find the center gravity. So I have it marked there. I just stuck on the pen and found the center gravity, which way is it gonna be. So now I know the measurement from the back of the motor to the center gravity here. That's where my motor will be sitting, and there will be around 15 mils up and down for moving. Same as I done here, and I done in here. So once I take off the tape, I will get the height. I will move the camera up and down. Also, I will move this one up forward to the very top, just to have the max position, to make sure when you're tilting the camera it's not hitting the gimbal motor. So another update on the pitch axis. I added here one bit, because when I was holding the camera and I was shaking, I noticed there was a tiny little swinging onto the pitch angle there. I could have left it there, I suppose, but it's just my little OCD. So it's all bloody rock solid, all good now. Okay, let's move on the yaw axis. Yaw axis. So started moving on this one. As you can see, I started doubling already. Just wanted to show you before I refine it. Like everything is sunk in, and on top of that, I'm just cutting a bit of a bigger piece, glue it on, and then I will sand it flush. Just save me some work instead of cutting so precise and then trying to glue it so precise. So that one was glued on, then sanded on, glued another bit on, and so on. So here's gonna be my yaw motor for controlling the center gravity. My roll motor will be sticking on here. Now before I did that, I got from the cardboard. I cut from the cardboard template. Also bear in mind the width, and I checked how much will I have of a roll. Make sure it's not hitting this one. So I will have roughly around 50 degrees each side. Well, one side is even more, which is plenty. And AP rig, if it goes 50 degrees, then it's not bloody recording a video, it's crashing down. Okay, finish that off and I'll show you what I have here. So here's my yaw angle done. As I suspected, I had to double the flanges as well, because even though I doubled the fiberglass in here, it was kind of tiny bit of a flexibility, which I kind of didn't like it that much. Now there's a 3.2 mil fiberglass all around. The structure is extremely solid. It'll be good. So there's my gonna be. Oh, I have to widen the hole a bit. So the turning and the raw angle, it's actually more than 50 degrees. And I checked the camera. It doesn't hit here. It doesn't hit here anyway. So I'll refine this a bit, and the next step, I have to grind this tiny little shaft, like between 4 mil sticking out, unnecessary. So it will be good to go. Now that's the interesting part here. Let's put on the scales. I know that the 2-axis gimbal are roughly, with the motors, are roughly 500 grams. So I was thinking of getting away with half a kilo of a 3-axis gimbal. So, oh, here you. Shut up.
Put it on that hand. Now do tweet. But that's
no, we have here 400 grams. Brilliant. It's gonna be some the copter mounting plate as well. So I will say I will not be 500 grams for the 3-axis gimbal, including the motor. Oh, shut up, you two. Right, so I'll get this refined. We'll make a plate, and then we'll be good to go and paint it. Okay. So I got my yaw axis finished there. It's all balancing good. Like the gimbal itself, it needs a bit of a balance. So I checked the flexibility from that point up to down up to the very this point, and it bloody looks, and it looks very good. So I mounted this handle, so I will do just basically a handheld test, whatever.
Gimbal is ginger.
What were you saying there?
This gimbal is ginger.
Oh yes, Mr. Wayne, it does come in black. And we're done. Okay, Well, I got my IMU mounted this way. Just threaded the holes to the plastic screws. I never knew. Always getting confused which one is the X, Y, and Z axis. So I just left another hole, just make sure I can make a turn or turning around whichever way. Got all the wiring done, everything, nothing obstructs. So there's no slip ring on the yaw motor, so the yaw will be only for dampening. Okay, so more or less we're done. All we have to do now is go do the handheld test. Okay, bye bye.